A new topic, Ingress Nginx. Okay, so till now, what we have seen various ways to access the pod, or you can say the deployment. So we covered it here. So we know what is pod, what is a replica set, what is deployment. Okay, and a small recap for services. Pod is ephemeral in nature. Okay, that's why we need to have one service, a logical layer where we can interact with the pod. There are various types of services. Okay, so one is cluster IP. Okay, which is for internal pod to pod communication, traffic within the cluster we can get using cluster IP. Okay, cluster IP service. Then in the node port there will be cluster IP for internal traffic, as well as a node port will be open on the worker node. This is the node port from which will interact with the outside traffic. Okay, and in the load balancer type of service, okay, there will be cluster IP will interact with the node port of the worker node, but from the outside world we can public IP is mapped to it, okay, via load balancer. Okay, so these two are not useful for outside communication. Okay, opening the node port is not recommended. Even if you open it, it should not be exposed and people should not be known that the node port is open. Okay, so we use load balancer. So suppose I want to have an example1.com website to be hosted, okay, on this pod, then we'll need one load balancer. Then example2.com, I'll need one more load balancer. Similarly, if I have 10 websites, I'll need 10 load balancers. Okay, and the public IPs are costly. Okay, and it is also difficult to manage so many public IP addresses, okay, on the load balancer. That's why we have Ingress. Okay, so what happens in Ingress? Okay, so Ingress, there will always be a service, okay, that will the cluster IP, the default cluster IP service will be there. Okay, and before that we'll install an Ingress. Okay, so Ingress will be installed in the Kubernetes cluster. Okay, and in Ingress will define various rules. Okay, that whenever a request comes to this website, to this pod it should go. If the means suppose this pod is for example1.com and this pod is for example2.com, so in this Ingress we'll write some rules, okay, that whenever the request comes for example1.com, send it to this pod service. If the request comes for example2.com, send the request to this pod. Okay, so that those routing rules will be defined in the Ingress, and Ingress will also run as a service on a load balancer. Okay, so to the outside world, Ingress load balancer, a single load balancer will be created. Okay, and it will be facing the internet. Okay, so the request will come to the load balancer, but this is not the load balancer service which we are seeing here. This is still a cluster IP service. The Ingress will have a load balancer. Okay, so load balance request will come to the load balancer. Okay, suppose the request is for app.example.com. Okay, it will come to the load balancer of the Ingress. Ingress will check the routing rules for which pod or a service it is, and it will route it to that particular service. That's the work of Ingress. So this is how it will work. The traffic will come to the Ingress. In Ingress there are 3 routing rules defined here. Okay, and based on whatever the rule and the traffic comes, it will send it to the pod. Okay, so how the deployment works here? So we'll define a deployment. Okay, and we'll have the labels. For example, here with the label is Nginx. Okay, then we'll create a service. The service will be cluster IP, and again it is mapped to a variable. Here the this label is selected. Okay. And again here one more service, the service which is created, for that service we have defined routing rules here in the Ingress configuration. Okay, so here it says that whenever the request comes to /foo, okay, it should go to my service, that is here. Okay, for bar we have not given service here, but for bar there will be a different service where the rules are defined where it should be routed. Okay, that's how the ingress works. Okay, so today we'll see one lab on ingress as well. So till now we did the deployment using kubectl. Okay, that is using imperative commands as well as using manifest. Okay, today we will learn one more new method. Okay, that is using helm charts. Okay, so we'll learn what is helm. Okay, so for the time being, considered it as a package manager for helm clusters. Okay, so which package manager we use on Linux? It is for Debian or Ubuntu based system. We use apt-get. Okay, for Red Hat based system like a Fedora, CentOS, or Linux AMI, that is Amazon AMI, we use Yum. Okay, so similarly, consider Helm as a package manager. Using Helm, we can install various services, or suppose we have to install httpd nginx, then using simple helm commands we can do that. Okay, so we need to first install helm on our server, that is our bastion host, or we can say a DevOps VM. Okay, there we need to install helm, and via helm will interact with the cluster. So let me install helm first. So for that I have created a script. We'll use that script to install helm. Remember, the helm should be installed on the system or a bastion host or a jump host from which you are connecting the cluster, like the kubectl. Kubectl is also on our cluster, right? Every day we use kubectl get all or get nodes. Okay. Similarly, we'll have to install a helm package as well. Okay, so the script for that is this helm.sh. We can say cat helm install .sh. Okay, so it was very quick. It has installed the helm. Okay, so we can check if the helm is there or not. Okay, it is at this location. We copied it. So helm is installed. So like apt-get or yum, we need repositories. Okay, for example, this is cat. Okay, I'll become root first. This is Red Hat based system. Okay, the Amazon Linux is Red Hat based system, and on Red Hat based systems we use yum. Okay, so if you go to here cd/etc yum.repos.d, we have these various repositories mentioned here. For example, in Amazon Linux repo, we have these repositories. Okay, and at the backend, whenever we try to install some packages, it refers this mirrors, or you can say sites, and from there it tries to download that package and install it. But we do not come to know that these repositories exist. Okay, but they are. Similarly, will need helm repositories as well. Okay, for downloading a particular package or service, will need the repository. Okay, and actually the helm charts, why I'm calling it helm charts, because these helms are created in a particular format. Okay, at the backend it uses the manifest only. Okay, so the helm charts from the scratch we are not learning now, we'll learn it later, but we can create our home helm charts which has various manifests to install something. Okay, and then we can package it and save it. Okay, so there is a website called artifacthub.io. Okay, here everyone stores their Helm packages for free. So Nginx is one of the companies which is making it available for us for free, the Helm charts. Okay, so various Helm charts which has inbuilt various manifests that is available on this website Artifact Hub. So here we can check for various packages, or you can say charts. So I'll just search for Ingress Nginx. Okay, so this is the first one. So we should select the one which has most of the subscriptions. Okay, and all. So this is the site which we are referring to install Ingress, Nginx Ingress. If you are not using Helm, then we'll have to download the manifest which are required. That is also available on the Nginx website. Okay, so those using those command, we can even install the Nginx Ingress, but we'll use the simplest method, that is Helm. Okay, so for that the same method is used here. So we have Helm. Okay, using Helm repo ls, we can check which repositories are there. Till now we haven't installed any repositories. Okay, again the repositories will be installed on this DevOps VM, not on the Kubernetes cluster. Okay, on Kubernetes directly the deployment of the Ingress will be done. Then then using Helm ls will come to know what is installed. Still nothing is installed. We can check in various namespaces as well. We'll soon cover what are namespaces. Now let's start the installation. So this I have copied it from here only. Okay, this is actually from here. Okay, so installation instructions are given here. This I am doing here. So I think we missed one step, that is and adding the repository first. Okay, so Helm, this is the command. So if you do Helm repo ls, we do not have anything here. Just add a repository. Now if you do repo ls, you can see an Ingress Nginx chart is installed here. Okay, the repository you can see. Now we can run the next command, that is this one. Repository is added. Now install the chart. Okay, so I can even take it from here. The same is given in the documentation. I'll just press enter. So instead of my Ingress, in the documentation it is only Ingress, so this name we can change. Okay, so it has installed it. Okay, and it is also giving an example how to use an Ingress. Okay, means how the routing rules should be written and all these details are given here. Okay, but we also have it in the documentation. So our Helm repo is there. Okay, and if you do Helm ls, we can even see which chart we have. We have named it as my Ingress Nginx. Okay, and it is deployed. So when it is deployed, just go to kubectl get namespace. Okay, so it has created the Ingress in kube system itself. Okay, so we'll have to change it. We do not want it in a kube system by default. Okay, sorry, it is in the default namespace itself, because we have not given any namespace. So if you see here, it is installed. Okay, but we do not want it in a default namespace. We want in a particular namespace. So what we will do, we will uninstall it. So how to uninstall a chart? Just use Helm ls and then do Helm uninstall. the chat name. Okay, so this will uninstall it, and if you see now kubectl helm ls, there is no chat there. And if you see kubectl get all, so it started deleting everything. Okay, so it also created a load balancer. We'll see it again. So it started deleting whatever it had installed in the default namespace. Okay, when it's done, we'll install it in a proper namespace. Okay, so if you see kubectl get namespace, we have kube system. Okay, and these are the default ones. Kubectl get pods. Okay, in all the namespaces, we'll write it in uppercase A. These are the only pods running as of now. Okay, and these are the namespaces. So we'll use the same command again, helm install. Better to take it from the document only. We'll use the same format given in the document. So here is the command. So what it does, it will install Ingress Nginx chart. Name of the chart is this. Okay, it is taking it from here. Okay, this repository. In this repository, it is checking for this chart Ingress Nginx. Okay, it is installing a particular version of it. Okay, it is saying that install it in this particular namespace. Okay, and if this namespace doesn't exist, create the namespace. So there is an option called -FN create namespace if the namespace doesn't exist. Okay, so whenever we install such different packages, we should keep it separately in a separate namespace. That's why I've created this names Ingress Nginx Ingress namespace. Now if I do kubectl get namespace, we have a new namespace called Ingress Nginx. Okay, and we can say kubectl get pods -a will show the pods in other namespace as well. That is Ingress Nginx. Okay. The better method is kubectl get namespace, and in a particular namespace, check for all the pods and services which are running. Get all. Okay, so if you see a pod is running, okay, so these are you can say, in short, an Nginx server is installed in a separate namespace. It is running as a pod here. Okay, and it has a load balancer service. Okay, and this is the load balancer's internal IP, and this is the external IP. Okay, so when we saw here, so this we have done now. Okay, Ingress managed load balancer we have as a service here. Okay, and this Ingress we have installed. Now next we'll be writing the routing rules which we need. Okay, so this is important. You should have this external IP. Okay, so if you see, it is nothing but a load balancer. Okay, with a public IP address. Okay, generally there are two public IP addresses. It will show it in some time, I think. So this is important. We should have a load balancer Ingress. Okay, now it's time to write our routing rules. And we can check. If you see helm ls, okay, it will not show anything. Okay, because it is showing the details of the default namespace. We need it for Ingress namespace. So let's get the name of the namespace and then do helm ls -n in the namespace Ingress Nginx, check for the chat. So this is the chat installed in the Ingress Nginx namespace. So let's wait. Still it's showing one IP, it's okay, but it will show two IP addresses in some time. Now let's create a deployment. We'll create two web applications. Okay, first one will be web app 1. Okay, httpd web app 1, and the second one will be web app 2. Okay, and till now we have seen that we write a single YML file. Okay, for deployment, then for services also we write a different deployment file. Okay, but it is possible to club many YML files in a single file. Okay, but a separator should be this three dashes or three hyphens. Okay, so in the single file http web app 1.yml, I have this deployment.yml, service.yml, and for ingress also I have. So all the three files are in a, means three definitions of YMLs in a single YML file. So let's create first application, then I'll explain it. So cat web app 1. Okay, I'll save it. So if you see, we have a deployment. Name of the deployment is httpd web app 1. We'll have two replicas. Okay, and we have defined a label app equal to httpd web app 1. Okay, and it is using httpd image to run the containers. Okay, then we have a cluster IP service here. If you see, I haven't defined which type of service it is, so by default it will be cluster IP. Okay, and inside the container it is working on port 80, and even the service will be on port 80. The service which will create cluster IP will have a port 80. Okay, and then we have this ingress rules defined here. Okay, so this is for the first application, that whenever the request comes for webapp1.example.com, okay, send it to this service. Which service? This one. Okay, which we have created on port 80. Okay. Similarly, we'll create one more application, but it is having the name as webapp2.example.com as an ingress. So here if you see, we'll not use two load balancers, only a cluster IP that is also for internal communication from outside world. We'll access it using a single load balancer. How? We'll see next. Okay, so if you see it here, kubectl get all, we do not have anything in the default namespace. Next, we'll just do kubectl apply -f httpd web app 1. Okay, so it has created a deployment, a service, and an ingress. Similarly, let's do it for web app 2 as well. Okay, so if you see kubectl get all now, we'll have, okay, two services, web app 1, web app 2, both are on port 80. And inside the container also it is working on port 80 because httpd works on port 80. Then we have these two deployments, web app 1 and web app 2, as both have two replicas. Here these are the two replicas for web app 1 and these are the two replicas for web app 2. Okay, now to access it, what we used to do, we will go inside the pod and we'll do curl localhost or curl cluster IP. Okay, but if you see, Now there is nothing is exposed to the outside world here. Okay, so everything is exposed using ingress. So in kubectl get all will not get the ingress details in a default namespace, so we'll have to do kubectl get ingress. This command we are running in a default namespace, and if you see, the first ingress is created and this is the second ingress. Okay, and it is pointing to some public IP addresses, that is the load balancer. And if you see kubectl get namespace will do, because you should choose this correct name, kubectl -n. Just copy this and get all. So in ingress, if you see, this is the same load balancer which is assigned to both. Okay, and ingress has routing rules which will send only web app 1 to web app 1 service and web app 2 to web app 2 service only. Okay, and it is using a single load balancer. If you see, it is ending with 76. This is also ending with 76, AC7 and AC7. Okay, so we do not need multiple load balancers. Now how to access it? Okay, now this example.com, okay, this is for internal use. From the outside world, it is not resolvable. Resolvable means if you do host, okay, web1.example.com, no one has this registered. This domain name is not registered with anyone, and when I run this command or ns lookup, you can say, it will not get resolved. Okay, so server can't find web app 1 because this is not the public domain. This is only for testing purpose. Okay, and and if you want to test it locally, okay, so we need to make an entry in a cat/etc host. Okay, when we will have an example on cert manager, after this we'll be covering cert manager, there will use the real domain, but now we are just using the internal domain. This is webapp1.example.com. So to make it resolve internally, okay, we'll have to make an entry in this file. So I'll just become root sudo space su, go to this file vim/etc/host, but let's first resolve it. Okay, or you can take it this same it is, just do first host. We just need to get the IP address. Okay, so if you see, there are two IP addresses. Okay, so even it is trying to maintain high availability at the backend, so we need these two IP addresses. So what we'll do, vim/etc host. So let me first copy it in the notepad. So in this format, we'll have to write it. IP address and then the domain name. So what is the domain name? Web app 1 and web app 2. So both web app 1, web app 2. So generally when we practice on some other Kubernetes cluster which are for testing purpose like Minikube, MicroKTs and all, okay, it will not have the load balancer, so we have to use some internal naming. There will have only single IP, but as we are using AWS, it will give two IP addresses. So on both the IP addresses, we need to map it. So whenever the request comes here, it will go to this public IP address, that is load balancer. So we need to make these entries in cat/etc host. So this is not required in a production environment. In production environment, we'll see how to do it in the TNS tomorrow or after this exercise. So we have made this entry and we'll just try to access it now. Curl web app 1. Okay, it will show it works. and even for web app 2 it will show it works. Now both are having same content. Okay, that's why it is showing the same page. But for testing, what we can go do temporarily, we can change the settings. kubectl get all, kubectl exec -it will go inside this web app 1 pod, one of the pod, /bin /bash. Okay, and in htdocs we have this cat index.html. Okay, I'll just overwrite it. Okay, this is app1. I'll just log out, and if I do curl now, okay, it's giving a response from this one of the pods. Okay, maybe if it gives from other pod, okay, this in this pod we have not made the changes. Okay, that's why it gave from this pod. Okay, so it will sometimes it will give from the other pod and sometimes this. Okay. If you make changes in both the pods in index.html, it will show the same page. Similarly, we can do it for other one as well. So in short, our routing is working properly. Okay, and what we have done, we have created a deployment. Okay, web app 1, okay, which has 2 pods running in it. Then we created a service for each, okay, both the deployments. That is, these are the cluster IPs and service name, port 80, and in we have defined an ingress where we have defined a rule that whenever the request comes, where it should go. Okay, and if you want to describe, we can describe if you want more details, then we can use the command describe. Okay, it is applicable for all the services, ingress, pod, deployment services. So if you do kubectl describe ingress, which ingress, just describe this one, you'll get some more details that whenever the request comes from web app, it will go to this service backends. Okay, and why 2 ports, 2 IP addresses? These are the IP address of both the pods, so it will go to either one of them. So the same thing we have defined in our YML. Okay, so this is web app 1, this is web app 2. So similarly, if you want to get more details of any other services, then we can also do that. kubectl describe. Actually, you should make a note of it. I don't think anywhere it is mentioned, so you can make a note of it. So describe the deployment. Sometimes this is useful for troubleshooting. If due to some reason there is an error, it will be mentioned here somewhere that there is an error, this is not working. So if you see, it is name of the deployment is web app 1, it is in default namespace. Okay, then nothing much, but some details are given. Similarly, we can get the details for kubectl describe pod. Okay, any pod we can describe. Let's take this one. So I have used both pod and pod slash. So this is again giving some more information. One more thing, we do kubectl get all. Okay, suppose I want to get only services, then I can use service or only SVC. Sometimes I'll be using service, sometimes SVC. Both are applicable. Then if you want only the deployments, then we can do deployments or just deploy. If you want only the pods, we can do kubectl get pods. Okay, and if you want everything in all the namespaces, just add uppercase -a. It will show all the pods in all the namespaces. So in default namespace we have this. In Ingress we have this pod. Okay, so it is not only applicable for pod. If you want all the services from all the namespaces, we can get that as well. Okay. And last one is kubectl get endpoints. So by default will give for default namespace. So endpoints are nothing but the real pods or containers, okay, their IP addresses on which port they are running. That we can get the endpoints as well. And if you want for all the namespaces, just add -a. Okay, so that's it for this exercise.